Eric Rosvold, and I'm the chair of the Vision Centric Challenge for this year. It's good to see the challenge brought back to Robofest, as was a key area of the competition. What I'd like to do is go through quickly the competition layout and what we're going to do, just so that you can be better prepared for it, and give you a quick demonstration. So, learning objectives. Basically, you can go over this. It's in the presentation. Understand vision processing, and gives them a unique ability, other than a lot of the game robots, to use the computer vision processing information. So each team, and there's only 2 teams this year, will be given. Be given a sample part, a drawing, and an inspection report for that part. Now, during the competition, you'll have 10 nearly identical parts. The only differences are the manufacturing tolerances for those parts, and the objective is to measure those manufacturing tolerances and report which parts are in print and which parts are not. The sample part will be given along with that, and you have 45 minutes to do the programming. During that work time, no adult coach help is allowed. After the 45-minute, teams walk away from their robots. We're not impounding the robot, you're just leaving the robot alone. The game synopsis, we'll do 3, 2, 1, start. The robot must measure 10 samples with 5 dimensions each and what we call a key product characteristics. So the robot reports if each part is in tolerance, each dimension is in tolerance or out of tolerance. The robot reports if the part is good, pass or fail, and the robot reports the value of the key product characteristic. Actually, reporting the overall part pass or fail is just whether there's any single fail or not, and there's no points associated with that. You have 2 minutes to complete the task. Students operate the robot, judges do not do anything with the robot, and teams must output the results to the screen. It can be in any format you want, as long as we will get those results, and you'll see in a demonstration I'll put on in a minute what we would do. The unknown factors will be on the blueprint, and that's basically what the dimensions of the part are. There's no other unknown factor like calculate an area or calculate something else. 1 restart is permitted. So in the competition, you don't know what the lighting is. It's in the racquetball court, but we don't know, or former racquetball court, but we don't know what the lighting conditions are there. So you should be prepared for whatever lighting conditions exist. You'll be given a table for the robot, and the PC or laptop is in addition to the robot dimensions. So you'll be given a part. They'll be approximately 6 millimeters thick. They may be a 1/4 inch, which is 6.35 millimeters. And within the dimensions of 250 by 50 millimeters, it will be made of aluminum. Each part will be identified with the serial number, so we know which part you're measuring. Sample part programming, again, is 45 minutes. During the programming, you're given the part, you're given the drawing, and you're given what the dimensions of that sample part are. So, for example, if dimension 1 is supposed to be 80 millimeters, and this one is 80.012 millimeters. So the parts will all be measured with a very precise CMM, so we know exactly what the dimensions are prior to the competition. So you'll be able to calibrate your device at the time of the game to make sure it matches what the sample is. You're given the dimensions are only going to be linear, ordinate. So linear, which is a dimension like this, a linear dimension from end to end. Ordinate dimensions where you go 0 and then you have a number of linear dimensions from that. diameter dimensions, so the diameter of holes, radius dimension, radius, say in the corner here, and measurements of angles. We're only going to give you plus or minus tolerancing. Scoring will be done by the judges. Each dimension correctly called out is 1 point, 5 per part, and 1 key dimension per part is measured with accuracy points. We'll get into that in a minute. The results will be posted when the teams have completed their runs. Round 2 is the same, except for it's a different part. So scoring of each round, you've got your measurements, and so basically those measurements will be made after the round is over, or be recorded. Again, an example of scoring. If you want to look at more information on this, look at the presentation on the Robofest site. So I'm going to go give you a demonstration. So I've 3D printed 3 sample of this, Cybertruck looking part, and I will demonstrate measuring those. So the first things to notice is that the datum structure, it's going to be sitting flat on one face, aligned on this, and then aligned on this end is the default alignment. And then we have key values. We've got dimension 1 is the radius of this wheel well. Dimension 2 is going to be the angle back here, this overhang angle. Dimension 3 is going to be the center to center of the wheels. Dimension 4 is from the base to the peak of the roof. And dimension 5 is from the front of the vehicle to the electric plug in the back here. And each one of these dimensions has a tolerance. Okay, so now I'm going to show you the device that I'm using for this demonstration.
Okay, now I'll demonstrate how the competition is going to go. So here I've made 3 samples, and in the competition there'll be 10 samples. And so you'll be given one of these apart with the actual measurements, and it'll be very close to the target measurements, but then all of the others will be slightly different. So as if you can see here, when I put these on top of each other, see that there's a slight difference here between those. And again, another difference between these. So all of the parts look similar, but they're slightly different. So it's not you'll be measuring different parts, you'll be measuring different manufactured to different tolerances. And so you're going to be trying to measure those. So here is just a mock-up trial system that we've got set up for measuring, and we'll show how that works.
Okay, here I'll try to give you a quick demonstration of a measurement system. So I'm going to place the sample part on the device and measure it. Let's see, we can measure it here. Okay, so that one's measured. Place the next part on the device. You can do this however you want to do it. Measure that one. And I'm just alternating between the parts. You'll have to process these in sequence with the parts. Actually, in any sequence you want, but you'll have to report them by sequence. Part. Other part. Six parts, a few more. report. Okay, so if you look at the top of the screen, I've got my team name, I've got 5 dimensions, pass, fail, and I have the key product characteristic measured. Now, however you want to report that would be great, and then we will use that for the scoring portion of the competition. Now that you've seen the demo of the run, basically this is showing how displaying the results, and the example you saw before was fine. Then the next is robot specifications, which we've gone over already. So basically, virtually any size that fits on a tabletop, it's going to be okay. Up to 2 cameras, although you can do probably everything with 1. Human-robot interface, basically, you have to press the keyboard, just press the space bar in order to do the measurement. So just like you saw in the demonstration, it was just a single key being pressed to do the measurements. Allowable violations. So the World's Championship is coming up this weekend, and so we're looking forward to meeting the teams. And if you have any questions, please let us know. We hope you enjoy the competition, and I will see you there. Thank you.